So I just realized I never recorded the second part of the notes from the other day. I was updating Canvas and realized I did not have a video for it. So I am going to quickly run through the problems that we did in class on finding the missing value when you know that the piecewise function is continuous. And I know we didn't get to the last problem in our notes, so I'm going to go ahead and include that here as well. All right, so we picked up with problem number 9 that day. So that's this is the continuation from the first video, but you were given a piecewise function. That's just a fancy name for a function defined in pieces. All right, and you were then told, all right, that if we know g of x is continuous, okay? Now I'm saying it's continuous everywhere, but because it's a piecewise function, we would be most concerned that it would not be continuous at 1. But so I'm telling you that we know that g of x is continuous at x equals 1. All right. I want to know, so if we know that, I want to know what must the value of k be. Okay. So if you notice here, we have that missing k value, and I want to know what would k have to be in order for this thing to be continuous. All right, and so we have to remember the three conditions for something being continuous. Is that f of c, okay, has to exist. That means every single point has to be allowed to be plugged into the function. And since this is a piecewise function that changes at 1, that's the piece that we'd be concerned about. So we need to make sure that f of 1 exists, okay? Then we have to make sure that the limit as x approaches 1, I guess that should be g, excuse me, g of 1 exists. The limit as x approaches 1 of g of x exists. And technically, we do need to make sure that g of 1 then equals the limit as x approaches 1 of g of x. Okay, so those are the 3 conditions for being continuous. All right, so we just need to kind of go through them and check it and see if any of those give me a way to solve for k. All right, so if g of 1 exists, but I'm allowed to plug g of 1 into the top function in place of x, all I get is that g of 1 equals 8. Well, that doesn't tell me anything about k. So then I move on to the idea that the limit as x approaches 1 of g of x exists. Well, if that limit exists, that means that the limit as x approaches 1 from the left of g of x is in fact equal to the limit as x approaches 1 from the right on g of x. So if I take my piecewise function and I pick out the appropriate pieces, the left is actually the x plus k, the right is the x squared plus 7, and then when I find those two limits, okay, by plugging 1 in for x, I get 1 plus k equals 1 squared plus 7, 1 plus k equals 8, k is 7. So that's the one that actually gave me a way to solve for k. And so then this third criteria over here at the end, okay, that is just kind of like you can double check yourself. So we know g of 8 is 1, and as long, g of 1 is 8, and as long as k is 7, all right, so plug k back in and the 1 for x at the same time and check your limit from the left and right, you get 8 equals 8. So the limit does exist and it is 8. So this last piece here is just a verifying step. But again, I really just asked you to solve for k, and we did. Okay? All right, so then the second example that we did got a little bit more complicated, all right, because it had two missing values, all right? So I said, given that f of x equals, and I gave you a piecewise function that had three pieces in it and two missing values. Okay, so let me get that written up real quick. All right, so my piecewise actually changed at two different places. It changed at -1 and 3, and I can tell that by looking at my piecewise. Okay, so we change at -1 and 3, so that's important to notice. Okay, all right, and so, but then I want to say, like, if f of x is continuous, so I'm telling you that it is continuous, all right, and it'll just be easier for me to just say find a and b. Okay, so find the values of a and b that do in fact make this thing continuous. Okay, so we need to think again, what points would we most be concerned about this thing being continuous at? And that's where, again, I circled it a minute ago, but that's where you look at that -1 and that 3. So if this thing is continuous, then obviously f of -1 exists, right? And then the limit as x approaches -1 of f of x exists. And then, of course, those two things have to be equal. But f of 3 also has to exist. The limit as x approaches 3 of f of x has to exist. And then they have to be equal to each other. So I need to kind of show all of those things, and then hopefully that will give me a way to solve for a or b, or a and b, I guess. All right, so I'm going to come back over here to f of -1. -1 is allowed to equal x in the top line, so this answer is just 4 and I'm done. But to take the limit, because the piecewise changes at -1, I do have to check the left and the right of -1. All right, so the left is the top line, but the right of -1 is the middle line. All right, and then when I find those limits, I get 4 on the left and -a plus b on the right. And that by itself does not help me solve for a or b. So then I move on, all right, and look at my other interesting point at 3. So f of 3, well, I'm allowed to equal 3 in the bottom line, so that's just -8, all right? But the limit is the more important one because that's where the piecewise changes again. So then I need to check the limit as x approaches 3 from the left and show that it is in fact equal to the limit as x approaches 3 from the right. So when I check the left, I have to use the middle line. When I check the right, I have to use the bottom line. And now when I take the limit, I get 3a plus b equals -8. And by itself, that doesn't help me find a or b either. But as you learned back in math analysis, all right, if you have two equations with two unknowns, you can set up a system of equations and solve, okay? So what I'm going to do is I'm going to take my two equations and I'm going to write them in a way that lines up the a's and the b's and the equals and the constants. And then I'm going to try to see if I can solve. Now, some of you in class talked about solving by, like, solving one of them for b and then substituting that into the other one, and that is perfectly fine. I just chose to line them up and use a method called elimination, okay? So what that means is, can I change one of these equations so that if I added them, all right, so I essentially want to add these, but somehow when I add, I need one of the letters to disappear. So we talked about subtracting one of the lines, okay? And if I do that, all that really does is change the signs for one of the lines, and then my b's cancel out. So it didn't matter which line I chose, okay, to make negative, as long as you remember to distribute the negative all the way through. So then when I do that, I end up with 4a equals negative 12, and now I can solve for a. And then when I'm done with that, I can go back and plug a into either one of the original equations there and solve for b. Okay, so let's see. I'm going to go negative of a plus b equals 4. And then I'm just going to make sure I don't want to skip any crazy things. All right, b then, all right, is 1. Okay, and so that is my a and my b, which is what you were asked to find. All right, and you can always go back and plug them in together and make sure that f of negative 1 equals the limit as x approaches negative 1. You should get 4 equals 4. Right? And then f of 3 equals the limit as x approaches 3 of f of x. You should get negative 8 equals negative 8. Okay? And then the one that we didn't quite get to in class, all right, was number 11 on my paper. All right, so I'm going to, all right, given g of x equals, because I didn't get to one with a trig function in it, all right, if x is greater than or equal to 0, and then 8 over sine x, or 8 sine x over x if x is less than 0. Okay, and so I want to know, given that g of x, I'm going to even make this shorter, is continuous. All right, find a. Okay, and so here again, we're just going through the process. What does it mean to be continuous? It means that the function, right, can be evaluated at every single point. And we are specifically concerned about 0 because that's where the piecewise changes, right? So then I just need to make sure I'm allowed to plug in 0, and I am. I'm allowed to plug it into the top line. So f of 0 equals 3a, all right? And that by itself doesn't really help me with anything, all right? But it also means that my limit as x approaches 0 of f of x must exist, right? Well, if that must exist, then that means the limit as x approaches 0 from the left is in fact equal to the limit as x approaches 0 from the right. And so maybe that'll give me an equation to help me solve for a. So for the left, I use the trig piece, and for the right, I use the top piece. Okay? Now, we already know that the limit as x approaches 0 from the right, that's just a nice direct substitution, and I just get 3a. But from the left, direct substitution would actually give me 0 over 0. So then I have to remember that I have a special trig limit here, and that that's really just 1, and 8 times 1 is 8. Now I actually have an equation that I can solve for a. And so a this time is a fraction, and of course you can always go back and plug a back in, right? And then see if everything, if f of 0, so f of 0 would actually be 8. And then if I plug a back in right here, I should get 8 equals 8. So the limit is 8, right? So if I go back, all right, once I have a, I should get 8 here. I should get 8 here. And then f of 0 is in fact equal to my limit because 8 equals 8. Okay? All right, and then I really wanted you to practice some problems out of the book because I really do think they are really good problems. All right, but then I also created an assignment in Delta Math for you. All right, so I'll see you in class next week.